Hello everybody. I am Dr. R. Sabita, working in EC department, going to discuss the topic of propagation mechanisms in wireless communication. The contents under the topic are the introduction and the propagation mechanisms used in wireless communication and the need for the propagation models and the merits of propagation models. Coming to the introduction part of wireless communication, the three key players in wireless communication are transmitter, receiver, and the channel. So transmitter you use for transmitting the signal. As we all know, receiver is going to receive it. So in between the transmitter and the receiver, the signal is traveling in the form of electromagnetic waves. So it is necessary to define a channel. Channel is simply a propagation medium which carries the information from one end to the other. In the case of wireless communication, it is simply an open space, or we can call it as an atmosphere. Another term which commonly used in wireless communication is propagation. So propagation is a mechanism through which the signal is traveling from one place to the other. So propagation of radio waves are taking place in wireless communication, high frequency radio waves. For the signal to get travel from transmitter to receiver, there are certain mechanisms that are defined. They are reflection, diffraction, and scattering. All in turn depends on the surface on which the transmitter signal impinges before reaching the receiver, because there is no guarantee that signal coming out of the transmitter antenna is taking the line of sight propagation to the receiver at all times, because you have so many number of obstacles between the transmitter and the receiver. Either it may be buildings, or it may be mountains, or certain obstacles like vehicle also will be an obstacle for transmission. So there are certain mechanisms needed for the transmitted wave to be received at the other end. The mechanisms are reflection. First one is reflection. So reflection occurs when a wave impinges on a smooth object or a smooth surface. We can refer this as a large surface, in the sense that a signal impinges on a surface whose wavelength is much larger than the signal wavelength which you are transmitting. So next mechanism is diffraction. So diffraction occurs when an RF waves which is relieved from the transmitting antenna is falling on the sharp edges of the obstacle. Because when the signal falls on the sharp edges or spikes of the obstacle, it will take a bend and it will be received. So this is normally happening when we are at the mountain or a hilly area. So the signal relieved from a transmitting antenna will impinge on the spike of the mountain. It will get bended up and it can be comfortably received at the valley point. So though it is making the transmission, there will be a loss of energy at each mechanism. Next mechanism is scattering. So scattering will happen when a wave impinges on an object that is rough, or it has irregularities with the dimensions, and it has a wavelength lower than the signal wavelength. So this diagram shows the combination of all reflection, scattering, and diffracted waves. So when you see here, the signal coming out of the transmitting antenna is a single signal, and it is taking up different paths, either through reflection or through diffraction or scattering, and then receiving at the other end. So at each and every mechanism where it is undergoing, or we can say when it is impinges on each and every surface, its phase value is getting changed. There will be a loss imposed on the signal. There will be an attenuation also. So it will be taking up multiple versions of one signal. So you are calling it as multipath propagation. So finally, at the receiver end, we have to sum up the signals received through reflection, through diffraction and also through scattering. There will be some decay because of reflection. There will be some decay of power and energy because of scattering. There will be some decayed signal because of diffraction also. So all will be summed up at the receiver end. So in order to make this possible, it is necessary to have certain models that are defined for the propagation mechanisms. So where comes in the need for propagation models? So the propagation models will define what's the received power at the receiver end, combining or summing up all the signals which are undergoing reflection, diffraction and scattering. There are certain advantages or the merits of defining the propagation models. First point is, with the propagation model, it is easy to design, simulate and plan wireless system. So as a communication engineer, before designing a wireless communication system, it is necessary to design it, simulate and we have to plan it before implementing in real time. Also, this propagation model reflects the properties of propagation channel. Either it may be a line of sight propagation or it may be a non-line of sight propagation. And also, since the wireless channel characteristics are dynamic in nature, one signal model cannot be defined for estimating the wireless systems. So normally using the propagation models, we are estimating the power received or the signal received at the receiver end. Since the wireless channel characteristics are dynamic, they are not static at all, as in the case of wired communication, we have to update or we have to revamp the propagation model according to the parameters we are receiving for the channel. So modeling the propagation models, through this, the radio channel decides the coverage modulation schemes to be used for optimizing the communication parameters. In summary, we have discussed propagation mechanisms and the need for propagation model and methods for estimating the received signal and the merits of propagation models. Thank you.